How to run open source large language model part 2. In the last video, I showed you how to run a cloud GPU on your computer, and also we ran a small code of LLaMA 3.2 11 billion parameters model. The code basically inputted an image of a rabbit and asked the model to write a haiku about it. And it worked well. However, today I want to go a little bit deeper and I want to show you how to connect your repo to the cloud GPU and show you different hyperparameters that you can choose while running the model. Let's start. So first step, we're back to our runpod.io website and we want to run our cloud GPU. So let's deploy. All the details and all small explanations I already explained in the last video. So if you want to really understand better what do you have to do for this to work and why do we choose these parameters or these inputs, please check the last video. Today I will do this quickly. So we want to deploy our pod. I will choose the same NVIDIA instance as last time. Now the same environment. On demand, we don't start Jupyter Notebook, let's deploy. And it's activating. Let's wait a little bit more. Okay, so first things first, we don't forget to go to the settings of this pod, edit pod, and increase the container disk memory. Save. Now it will rerun.
A few moments later.
Exporting environment variables. Okay, now we want to connect. To do so, we click on connect and again we copy the ID of the root. We go to Visual Studio Code and now we want to connect to our host. So connect to host, add new host, enter. Yes, with my username, connected. Now we click again here, connect to host. And again, let's check the numbers so they fit. So these numbers here have to be exactly the same and the numbers of the SSH host, yeah. So that's the one. Now it will open you a new window. Continue. The password. Again, what am I doing here is explained very well on previous video. So if you don't understand something, really check it out. It's 14 minutes. It's really not that much time to at once understand how to run properly a GPU cloud and never had to research on it again. I really spent some time on researching how to do it properly and figuring out how to connect properly the code. And it took me much more than 14 minutes. So I think it's a pretty valuable information. Now, we're connected to our host and I created a Git repo for you where I already put the code of the model I want to run. So I will share the Git repo below the video in the description. And let's go to this tab called code and click on copy URL to the clipboard. So we want to kind of copy the path to this Git repo. It's public, it's available to everyone. And now we're going to go back to our Visual Studio Code and go to the terminal. And let's write git clone and paste the link. It's cloning. Good, it cloned. Now we have to go here to the Explorer, open folder, and we will choose the name of the repo, which was run LLM. Okay, and now we click on OK. And it will open as a new window. Yes, I trust the authors. And it will show you here the files, like a normal repository. It might ask you to install the Python language on the pod. And probably it will just install it automatically, how it did it with me. Okay. Now we have everything to run it. Let's start by running our requirements. So we need to install them. For that, we open the terminal. As you see, it's already connected to the pod. Let me just make smaller the window and we write pip install r requirements txt. Enter. Okay, It's installing all the packages we need. I can show you here. Basically, it's just a file, a text file with all the packages that I will use. And you don't need anything else. Then you can just close this file and have it here in the repo. And the only thing that you need is to just install them through this code. Okay, now everything is installed and we can run our code. So this code that I prepared for you today, the idea of this code is to run the LLaMA 3 8 billion parameter model. And the first part of code, you already kind of saw it last time. So it just has a tokenizer and it downloads the model. The second part will be the part with the message. And here you will specify the system prompt. So you are an AI assistant with expertise in natural language processing and AI model configuration. And now we ask the question, our prompt, the user prompt, what would happen to the responses if we set the temperature to a low value like 0.3 versus a high value like 1? Could you explain how it would change the style and predictability of the model's answers? So this question right now doesn't make a lot of sense, but when we will start talking about hyperparameters, which is like parameters or settings that you can apply to the model when it generates the output, it will make much more sense. Now in the input IDs, we need to specify how the model should generate the response. So we give it a message, we tell it that it should generate the response, and in what format. It just tokenizes the output into PyTorch tensor format, and this is necessary for the models in PyTorch. And finally, it moves the tensor to our device, which is basically the GPU cloud in our case. The terminator just signals the model when to stop generating the text. And finally, outputs is the most interesting part. So here we will actually define of how model should behave. And each of these small so-called hyperparameters will matter. So let's start with the max new tokens. In my case, I put 2048, and that's basically the max of the tokens that the model can generate, the LLaMA 3 8 billion parameter model can generate in total. This is given by Meta, the company that created this model. And honestly, playing around with this hyperparameter doesn't really matter, because even if I put it to a smaller amount, smaller size, for example, if I put it to 1,000, if the response is 1,200 tokens, what it will do, it basically cuts the response. And in the end, we have a poem or a sentence that is not finished and cut in the middle. So it does not really restrict the model to create a response with exactly that size of words, but it rather will just cut the text. The next hyperparameter is the do sample. This basically generates different samples or different answers towards the model, so with different probabilities. So what happens when we generate an output is during the decoding, we apply the softmax function on our logits, as I also explained in my previous videos, and it will generate several responses with different kind of probabilities. This process of creating the samples is what this do sample equals true does. So the next hyperparameter is temperature, and what temperature is basically when the neural network, so the large language model is a neural network. When we use the neural network, what it does, it generates the probabilities of the next possible tokens based on the context. So based on the previous context, previous text, it will generate the next token, right? And it applies the logit function with an output between minus infinity and plus infinity. This logit output of a specific token is then called UY in this formula here. And when the temperature in this formula, if you look at it, it's in the denominator, right? When it equals to 1, and the temperature varies from 0 to 1, these logit outputs that are related to the token probability are used as is. So the value UI does not change, right? Meaning we just plug the UI into the exponential function, and I will put it here, and the t equals to 1 in the denominator has no effect. If you lower the temperature, so if it goes closer to 0, the probability distribution sharpens, right? And this is because dividing by t is like jumping towards the right side of the distribution. However, when the words were already less probable, jumping to the right does not really affect their epsilon value. However, the more probable words, when they're lying closer to the right, there is a large change in their UI value. And this effect can be seen in this graph here. If you look at this graph, we have temperature of 0.5 for the orange axis, and we have temperature of 1 for the blue axis, right? And if you look at the low temperature of 0.5, we have a very large spike on the token that had already higher probabilities than other tokens. So in this case, it's I, the word I. And when the temperature is 1, the spike is not that big, and it's kind of flatter the distribution in the axis, the distribution of all the probabilities, right? This means that there is less uncertainty and the probabilities are closer to each other, so the model can choose from more tokens because it assumes that they're closer between each other in terms of probabilities. And we also would assume that because we set the temperature to 0, okay, there will be less hallucinations, so less answers that are incorrect, and the model says with certainty. However, there is new studies, and a paper from Google DeepMind was published not so long ago, where the team says that, well, it's not exactly the truth. Basically, by setting the temperature to the lowest value, we restrict the model to kind of have this effect of chain of thought that became a very popular topic right now. So chain of thought really increased the efficiency of how the model generates the answers. And because of putting the uncertainty to the minimum, we basically restrict the model thinking, and sometimes it just doesn't get to the correct answer. But this is a whole different topic, and it's pretty new. If you're interested on this topic, you can go to the description below and go to my LinkedIn page. This was the last post I posted on LinkedIn, and there is an article and a paper on it. It's an interesting topic, but it's pretty advanced. Okay, getting back to our code, we have the next hyperparameters that I want to talk about today is the top P, and this is called also in a different way, nucleus sampling. And basically what it does is, okay, we generated these outputs of different probabilities, and if we set our top P in this case is equal to 0.9, we only will consider for the output the first 90%, the top 90% of probabilities. So it's basically the tokens that are most likely to happen in the 90% probability mass, right? Okay, and this is basically the hyperparameters that I thought that are important to know to everyone, and they're interesting to play around with. If you have any hyperparameter that you think is interesting to talk about, let me know. I either answer you in the comment or make a short about this hyperparameter. Yeah, and I hope this topic was interesting for you. Now let me run this code. So let's go, let's run the model. And it will open the terminal directly with Python. And as you see, it's all on Cloud GPU. Oh yeah, and I already forgot that I need to add a code for the Hugging Face. Let me do it. So Hugging Face token can be taken on the Hugging Face website. I also explained in the last video where do you get it. So let's log in. Good. And this is my chance in the end of the video to show you how to push this into Git. So let's run again. So now I have to also import the package login from Hugging Face. I will run the Hugging Face with my token. I already explained in the last video how to get this token. So please check it. It's really important. It's like really cool basis on how to use these things. And I think it will be really helpful for you if you want to continue working with large language models. Now we run the model with the tokenizer. Okay, now that we ran our model, we'll run our message, which basically asks the model to explain us what will happen when the temperature is 0.3 versus when the temperature is 1. Let's go. Input ID is the one that will set how the model should respond to terminators, and one that will set when the model has to stop generating. And finally, our outputs, where we will generate our response with all our hyperparameters. Now let's wait. Meanwhile, while the model is running, let me show you how to, I will log in into my GitHub in order to push the new code, the updated one. So I have to open the bash terminal. And we write git config global user.name and my username from GitHub, which is Christina Schmidt, right? And like this. Okay, and then I will write git config global user.email, and now I have to write my email, which is the email associated to my GitHub. And that's basically it. And now we're connected. And when we go to the source control, and we will save this code, for example, we can directly put the message, for example, update of code, and commit and push. That's basically will push the code to the GitHub and update my code. So it finally generated the response, and it's quite big. So it explained that in a transformer-based language model, like the one we're using, the temperature parameter controls for randomness and diversity of model's output. A higher temperature value means model is more likely to generate more diverse and creative responses, while a lower temperature value means the model is more likely to generate more predictable and repetitive responses. Here is a breakdown of what happens when you set the temperature to a low value like 0.3 versus a high value like 1. So the low temperature is 0.3. The model is more likely to generate responses that are more predictable, less diverse, more focused on the most likely next word, and the model response may become more conventional and predictable. Now the high temperature equals to 1. The model is likely to generate responses that are more diverse, less predictable, more open-ended. So the model is likely to generate the responses that are open-ended and require more context to understand. They also may become innovative and uncertain. So in general, a low temperature value is suitable when you want the model to generate more predictable and conventional responses, while a high temperature value is suitable when you want the model to generate more diverse and creative responses. However, it is essential to know that the optimal temperature value depends on specific task, dataset, and desired output style. And not to forget about the paper I mentioned about DeepMind. The temperature does not restrict the model from generating hallucinations, but actually it may provoke them. So that's it for today. I think I showed you quite some stuff. So I showed you again how to connect the GPU and how to connect it to a proper repo, how to connect to GitHub, how to pull stuff there. We talked about different hyperparameters. Again, if you have something in mind, if you have a hyperparameter you would like to talk about, I will be happy to make a video about it. I hope you enjoyed this, and I wish you a very nice week, and I see you next time. Bye!